All right, welcome to Unit 10. This unit we're going to be talking about two formulas and how those formulas can help us to solve missing sides or missing angles from any type of triangle. So before we give you the formulas, we're actually going to show you this whole worksheet is discovering the law of sines right here. So law of sines, well, let's kind of start off where we know. We know how to solve for sides and angles of a right triangle. Okay, we talked about right triangle trigonometry last year. We had a whole unit on it review. Unit circle even had a lot of right triangle trigonometry. So these triangles that we're going to be talking about are not, notice this ABC is not a right triangle. We, however, are going to make it a right triangle by sketching an altitude. An altitude is just a line that forms a right angle. So we're going to start at vertex B right here, and we're going to draw a line that's perpendicular, or as close as we can make it look, to this line below. So that's just saying I am going to make it so that that is a right angle right there. So now we've got two lovely right triangles, this AB, whatever this point is, and CB, whatever that point is right there. All right, they want me to label that altitude K. So we're going to call that altitude right there K. The altitude now, it says it creates two triangles. So notice that angle A is in one triangle, so this is in one triangle, and then angle C is in the other triangle. And now what they're going to want us to do, slow down just a little bit, they want us to use our right triangle trigonometry, and we're going to write two equations involving A, actually involving the sine of A. So remember, our right triangle trigonometry, our so-called TOA, write that down up here, the sine of angle A, so the sine of angle A is going to equal the opposite, what that O stands for, over your hypotenuse, right, the H. So when we look at this triangle right here, again, guys, this is only looking, we kind of made two triangles, so now we're just looking at this lovely triangle right there. Okay, so the sine of A is going to be the opposite, which opposite of A is going to be that K right there, divided by the hypotenuse. The hypotenuse is across from your right angle, or that C. So the sine of A is just equal to K divided by C. Right there. And then they want us to do the same thing with the other triangle. So if you look at this triangle now over here, they want you to talk about the sine of C. So sine of C is also going to be your opposite over your hypotenuse. This time my opposite is again K, but this time the hypotenuse, the side across from my right angle, is going to be A right there. So we've got two lovely formulas, sine of A and sine of C. Now they notice that each of those equations have a K in it. Okay, K is the opposite of both of them. So they both have a K in it. And they want us to solve the equation for K. So if we have the sine of A is equal to K divided by C, they want K by itself, not divided by C. So we're going to multiply by the C, both sides. Remember, you've got to multiply both sides by C. So we now have that K is equal to C times the sine of A. All right, do the same thing for this one, for the sine of C is equal to K divided by A. This time we just want K, so we're going to multiply by A right there. And so A times sine of C is equal to K. So we've got two K's right there. I'm going to kind of highlight them. We've got K is equal to that, K is equal to that. All right, keep going down here. It says since both of the equations here are equal to K, we can say that they're equal to each other. So that equals K, that equals K, so K is equal to itself. We can go ahead and just say that the C times the sine of A is equal to A times the sine of C. Keep all these numbers and letters straight. They're big cases and lowercase letters straight. All right. And then 6 down here, it says now we've gotten rid of our K, which is actually what we wanted to do, because notice, look up here at this nice lovely triangle. K was a line that we actually drew. All right, the triangle to begin with was just ABC. So we've now eliminated K, so you're not going to have to do this for any of your other questions. We just have this nice lovely formula that we can use to solve for missing sides or missing angles. They also want us to regroup our little a with our big A and our big C with our little c. So when we do this, b times the sine of A, we'll just write that is equal to A times the sine of C. Basically what we're going to do is we're going to divide by the c. It's just multiplied. So we're going to divide by that little c right there. That way, those just cancel. Anything divided by itself is 1. We've still got it over here. But then we're also going to divide by this a. So we're going to divide by a right here. Anything divided by itself is 1. So notice what I'm left with right here. I'm left with the sine of A, sine of big A, that's my angle, over the little a, which is the side. That is equal to the sine of big C divided by little c. Now, this is a huge part of our formula. We're actually going to do this whole thing one more time. But before we do that, let's talk about this really quickly. The sine of big A over little a. And a lot of you are thinking, what is the difference between a big A and a little a? Let's go back up here to the picture that they drew, and we're just going to go through that really quickly. We're going to actually erase all these lovely little markings that I have in here. And we're going to notice one thing hugely. I probably should have pointed this out at first. When they label the triangle, and you can label triangle however you want, but notice right here, whatever letter they call that angle, angles are always going to be capital letters. When we go across the side opposite, notice it's the same letter, just as a lowercase. Always going to work like that. So capital B, go across from it, here's my little b. Capital C, go across from it, there's my little c. So the smaller letters are going to be your side, so these are going to be side measurements, little a, little c are side measurements, and then the sine of an angle, these big letters, A and C, are going to be your angles. All right, let's do one more really quickly, and then you're almost ready for the formula. This time we're going back. Notice this is the exact same triangle as before. This time our altitude that we're going to sketch, again, altitude just makes a right triangle. It's going to go from vertex C. So we're going to go from vertex C and try to make a right angle right there. And again, we've cut that triangle into now 2 right triangles. Okay, and they're going to say, call that K again. We're going to call that lovely little altitude K. All right, again, we've got 2 right triangles right inside of this triangle. Now we're going to talk about sine of A and sine of B. The last time we did the sine of A and the sine of C. This time we're going to do sine of A and sine of B. So when we look at the sine of A again is going to also be the opposite side, which is our K, divided by my hypotenuse, which comes across from the right angle, which is B. Okay, and then sine of B, we're going to have the opposite, which is K, over the hypotenuse, which is A right there. All right, we've got the equation with both of the k's in it. So we're going to do, this is the exact same thing, just a different altitude as before. So we're going to solve each equation for k. All I'm going to do is I'm going to multiply by b, both sides by b. So I know that k here is equal to b times the sine of a equals just cancel. And then over here, I'm going to multiply both sides by a to undo that divide by a. So k is going to equal a times the sine of b. All right. Now, again, these are both equal to k. Notice they're both equal to k right there. So they could be set equal to each other. So b times the sine of a is going to equal a times the sine of b. Fantastic. Notice again, no more k's, which is perfect. That's what we want. Again, our nice lovely triangle right there. We drew the k, so we'd like to do it without it. Now they just say, okay, again, group the a's with the a's. So we're going to divide both sides by a right here, so that we don't have a's with the sine of b, and then divide both sides by b. We're going to divide both sides by b. And so I'm left with the sine of angle A over side A, little a, is equal to the sine of angle B, or big B, over little b. All right, now what they want us to do last step, and you're done, and you're going to remember this forever because you are the one who discovered this. But we are now going to say notice right here we have the sine of A over A is equal to the sine of C over C. We've also had the sine of A over A is equal to the sine of B over B. So we can use this to say this. The sine of angle A over A is equal to this, which is the sine of B over little b, which is equal to the sine of big C over little c. All right, so basically the sine of the angle over its corresponding side is equal all across the board. Now, when we use this, we're only going to be using two of them, but we just want you to show that all three of those are the same. If we were to do the triangle again, we could do it and show that sine of B over B is equal to sine of C over C. We're not going to do it. This is just your formula that you can memorize. You can probably don't need to memorize it. It's not that hard to remember. But that's us done. So go ahead and snap a picture of this and send it to me. That's 3 points just right off the bat. And then I'll do some more videos for the homework in just a few minutes.